is 2014 10b, a particle moving in a straight line. We have acceleration 2t minus 3 at time t, and at time t0 v is 2, so we have initial v. Put that down, initial v is 2, and displacement of 1 meter relative to a fixed point O. The times when the particles are changing direction. Okay, so we have A and we need T, so A is dv dt. So that's equal to 2t minus 3. So dv is equal to 2t minus 3 dt. So we need to integrate. And change in direction is when velocity is equal to 0. We have our particle move, and we saw this change in direction only once in the previous question. So when will my velocities be 0? So let's integrate here to find velocity. We have the initial velocity of 2, and time, we're going to integrate t is 0 up here. So we're going to get just v between v and 2 equal to 2t squared over 2. If you want to write the whole thing out, 2t squared over 2 minus 3t between t and 0. So we're going to get v minus 2 is equal to t squared minus 3t. So we're going to get velocity is equal to t squared minus 3t plus 2, and when v is equal to 0 we get the change in directions. So t, what have we got, minus 2 by t minus 1 would be equal to 0, factorize it. So it changes directions when t is equal to 2 and when t is equal to 1. What are we asked? The times when it changes direction. So t is equal to 2 and t is equal to 1, and an expression for displacement. So s from O at time t. So we have here our acceleration, which is also equal to v dv ds. So v dv ds is equal to a. And down here we have velocity, which is ds dt. So which one of these are we using? Displacement at time t. So ds dt, we have our velocity. So ds dt is equal to t squared minus 3t plus 2. So displacement in terms of t is when we're going to integrate these two things. We're given some information on displacement at time t. I think it's all the same units, isn't it? Meters, maybe? Meters and seconds, yeah. So displacement of 1 meter. So displacement of 1 relative to t. So we're going to get s between s and 1 equal to t cubed over 3 minus 3t squared over 2 plus 2t between t and 0. So we're going to get displacement s minus 1 is equal to t cubed over 3. Are we given a time interval here, or just in terms of an expression for displacement and then total distance traveled in the first 2 seconds? Okay, so t cubed over 3 minus 3t squared over 2 plus 2t, and then it'll be plus 1. That's what s will be equal to. We can cross this one out. And then what the distance traveled in the first 2 seconds. So it's one of these change of directions questions. It's going this way between 0 and 1. 0 to 1, and then let's say it changes direction 1 to 2. So we're going to put integrate, so we're going to get when t is equal to 1 firstly, so s is equal to, this is when t is equal to 1. S is equal to 1 over 3 minus 3 over 2 plus 2 plus 1 plus 3, we can just say. So S is equal to, we've put them all over 6, we've 18 and 2, 20 minus 9, 11 over 6. And then between 1 and 2, we're going to have to put 2 in. So we integrated between 1 and 2, we're going to put the 2 in and then the 1 in. So that's when t is equal to 2 first. Then we're going to have to take away the 1, if you know what I mean. So t is equal to 2, s is equal to 8 over 3 minus 3 times 4, 12 over 2, 6 plus 4 plus 1, 5. I'm putting all of these over 3, 15 and 8, 24 minus 18, 6 over 3. So s is equal to 15, 23 minus 18, 5 over 3. Distracted by the dog drinking the water. So it's going to be 5 over 3 if we put the integral in. 5 over 3. That will be, and then it'll be minus 11 over 6, and it'll be the absolute value of this guy plus this guy. So we're going to get 11 over 6 plus, this will be 10 over 6 minus 11 over 6, which is 1 over 6. So we have 11 over 6 and 1 over 6 is 12 over 6, which is 2 meters. But didn't it start at 1 meter? It started at 1 meter. So then the total is equal to 2 minus 1, which is 1 meter. Just use a calculator earlier in this question.